Now we will solve another problem. Again we are going to find out the characteristic equation. Show that the matrix 2 by 2 matrix satisfy its own characteristic equation. Okay. So let us see. So A is given as this 1 minus 2, 2, 1. The characteristic equation of the formula is given as this formula, and S1 is nothing but sum of the main diagonal elements, and S2 is nothing but det of this matrix. So main diagonal elements, that will give you 1 plus 1, which is equal to 2. Det of this matrix is nothing but 5. You just substitute here, you will get lambda squared minus 2 lambda plus 5 equals 0. Okay, this is a characteristic equation. What is asked? Satisfies its own characteristic equation, whether it will satisfy its own characteristic wave equation or not. So for that, what we are going to do is, you substitute in place of lambda, you substitute A here. In place of lambda, you substitute A. So you will get A squared minus 2A plus 5. I can multiply with identity matrix. The answer will be the same. So I can write this as plus 5i. Okay. Now this is A. I will have to find out A square now. So A squared is A multiplied by A will give you A square. Already we know about A very well. So substitute in this equation. So this is where A square minus 2A plus 5i. What is the answer? It should be 0, because it has to satisfy its own characteristics. What is the right hand side? 0. So you will get 0. It itself will satisfy. Is it okay? Right hand side is 0. You must get the answer as 0. So this is the characteristic equation, and it should satisfy its own characteristic equation. So sometimes the question is very difficult. This question may be asked. Okay. Verify that A equals 1 to 2 minus 1 satisfy its own characteristic equation, and hence we are going to find out A to the power 4. We are going to find out A to the power 4. This is at the most we will get only, this is 2 by 2 matrix, correct? We will get in terms of only lambda square. That will be in terms of A square. So what is asked? A to the power 4. So A square multiplied by A square will give you A to the power 4. That's all. So you will get, you have this matrix A, use characteristic equation and find out S1 and S2, substitute, you will get this equation. Very simple. Sum of the main diagonal elements will be 1 plus minus 1, so 0. So your S1 will be 0. What is the det A? Minus 5. You substitute here, so lambda square minus 0 lambda minus 5, so lambda square minus 5 equals 0. So what is asked? Its own characteristic equation. So this should be replaced with A. So A squared minus 5i equal to 0. So what is A squared? A multiplied by A. So that will give you 5005. You have to multiply A with A. Matrix multiplication. So that will be 5005. That is your A squared. A squared minus 5i. This is your A squared minus 5i will give you 0. So that's why we can say that it satisfies its own characteristic equation. So this is your A squared minus 5i, which is equal to 0, 0, 0. So answer is 0. Now what is asked? Another one? A to the power 4. We know that A squared equals 5i. A squared minus 5i equal to 0. So A squared equals 5i. So I can write A to the power 4 as A squared multiplied by A squared. One A squared I can write this as 5i. Doesn't matter. So you will get A squared 5. I repeat, A to the power 4 equals A squared multiplied by A squared. What is A? What is A? 5i. What is another A? That also 5i. So you will get 25i. 25i squared. Is it okay? A to the power 4 equals A squared multiplied by A squared. One A squared is 5i. Another A squared is 5i. Correct? So 25. Then you will have 1001, 1001. You have to only go with a matrix multiplication. You should not go with direct multiplication. You should not say 25i squared. I squared means 1001, again 1001. That will give answer as 1001 only. You will get 250025. Or otherwise you go with 5a square 5 multiplied by your a square, that will give you 25, 0, 0, 25. So that is the answer, a to the power 4. Okay. Now the next session. Next session is eigenvalues and eigenvectors. So as I said, eigenvalues, eigenvectors, we are going to have the linear transformation. We are going to involve linear transformation only. In transformations, we discuss about 3 transformations. One is linear transformation, another one is rotation transformation, another one is shear transformation. Can you remember? Shear means, suppose if you have a box, you are going to apply the force only at the top. So, okay, at the top. You are going to apply the force only at the top. So what will happen? The top will move this way, bottom will be there. Bottom will be stagnant there itself. The top alone will move like this. And this is called the shearing stress. Shearing. Probably we have studied in shear and stress earlier. So this is shearing. This is also transformation. Rotation also is a transformation. But eigenvalue problem and eigenvectors problems, they involve only linear transformation. Okay. For example, this is a linear equation. This is the eigenvalue equation, but it is a linear equation. Because the operators involved as linear, so linear operators are there. For A matrix will be always a linear transformation. Linear operators are involved. Lambda is the eigenvalue. A operator, it's a matrix, operates on one system, usually some function will give you eigenvalue with a function. This eigenvalue can be a positive value or negative value. Positive value means direction is positive, stretches, it stretches. For example, the stretching is, for example, this is say for example this is 1 meter, you can say, and you are going to stretch into 2 meters, 3 meters. This is called the stretching, linear transformation. It will go in the negative direction. Lambda, if lambda is negative, it will go in the negative direction. So lambda can be either positive value or negative value. This direction also we can have. So this is eigenvalue equation. It's a linear transformation equation. So let Aij be the square matrix, and this is applicable only for the square matrix. We are going to deal only with the square matrices. Okay. Suppose there is an n-dimensional non-zero columns vector x such that the action A on x will give you some other value multiplied by x, and this is nothing but eigenvalue equation using linear transformation. Remember this. So where lambda is a scalar. In other words, the transformation represented by the matrix A just multiply the vector x by a scalar lambda. Multiply. The vector x is then called the eigenvector of a matrix. This is your eigenvector. If both the things are same, you have a vector here, the same vector exists on right hand side, what we call this as eigenvector. Suppose if different vectors are there, for example Ax equal to lambda y, we are going to transform, then the equation becomes Ax equals lambda y, some other vector, what we call this ordinary vector. Suppose if there exists x, here also right hand side also if same exists, then that's called eigenvectors. So x is called eigenvector of a matrix A, lambda is called eigenvalue, proper value of A corresponding to the eigenvector x. So we can find out the characteristic equation, and then we can find out the solution of the equation easily using eigenvalue problem. Okay, so that's the idea. So Ax equals lambda x, which is equal to lambda ix. I can write this as lambda ix. You bring this term to this side, you will have A minus lambda ix equal to 0. X cannot be equal to 0, so A minus lambda equal to 0, which we studied in characteristic equation. Can you remember? A minus lambda equals 0. This is the matrix form of eigenvalue problem. Okay, for example, you have a matrix. A matrix is given as this. What is x? X is 6, 3, column vector 6, 3. You just have matrix multiplication. You will get 30, 15. You pull 5 out. You will get 6, 3. Here also you have 6, 3. This is your x vector. This is your same x vector. And this must be your lambda. So lambda is 5. Eigenvalue is 5. X is a column vector as 6, 3. X is a column vector as 6, 3. Right hand side also. You have matrix here. Is it okay? So few problems we'll try to solve. show x equals 1, 2, 1 is an eigenvector for a equals 2 minus 4, 3 minus 6. So Ax, you find out Ax according to the formula Ax equal to lambda x. So Ax is given as your A is here and your x is here, which is nothing but 0, 0. So your lambda is 0. As I said earlier, lambda can be equal to 0 also. Here lambda equal to 0. So lambda x equal to 0, 2, 1, which is equal to 0, 0. So the eigenvalue of lambda is nothing but 0. 0, okay? Any doubt? So again, one more problem in 2 by 2 matrices. So matrix A is given as this, A minus lambda I, that's the formula. So your A is here, minus lambda I. So you will get 1, 4, 2, 3, this can be written as minus lambda, 0 lambda. So 1 minus lambda, 4, 2, 3 minus lambda. We are going to find out the eigenvalue, okay? And what is here? Find lambda such that det A equal to 0. The condition is given. Det A minus lambda equal to 0. We will have to find out lambda. That's a question. See here, the question says det A minus lambda I, which is equal to 0. So this must be equal to 0. The condition is. From this, we will have to find out the value lambda. So det A minus lambda I. Det A minus lambda is equals 1 minus lambda, 4, 2, 3 minus lambda, cross multiplying with a minus sign, that will give you lambda square minus 4 lambda minus 5. This is equal to 0. It's given as 0. So this equation is equal to 0. So if this equation is 0, this is a quadratic equation. You can factorize, you can find out the solution. You can factorize this. Lambda square minus 4 lambda minus 5. You just factorize minus 5. You see, usually you just take the last term, minus 5. Okay. You just separate into minus 4 minus 1. You just try. Just try. Or minus 4 minus, no, 5 can be separated into only 5, 1. Okay. Either, see, I just take the last term, 5. You just separate. So that will give you minus 5 plus 1. First option is minus 5 plus 1. Minus 5 plus 1 will give you, you add these two will give you minus 4. Minus 5 multiplied by plus 1 will give you minus 5. See, you will get this. That's a factor. When you are going to add, you will get this term. When you are going to multiply, you will get this term. Is it okay? So you can factorize this. Lambda minus 5, lambda plus 1 equal to 0. So your lambda equals minus 1 minus 5. So lambda is obtained as minus 1 comma 5. The eigenvalues are minus 1 comma 5. Okay, for 2 by 2 matrix. Suppose when you are going for 3 by 3 matrix, how many lambda values will be there? 3 values will be there. Okay, for 2 by 2 matrix, we have 2 values here. Any doubt? So few more examples. So as I said just now, okay. So A matrix is given. First we have to find out A minus lambda I. So 2 minus lambda, 1, 1, 2 minus lambda, which is equal to 0. So this will be your characteristic equation. You have to find out the lambda value. So as I said earlier, you just take 3. When you are going to add these two, you will get minus 4. When you are going to multiply, you will get this one. The next one. Next one is your 3. So factorization, you will get lambda minus 1, lambda minus 3. So lambda equals 1 comma 3. So 2 values exist. See, 2 by 2 matrix, we have 2 values of lambda. Eigenvalues are 1 comma 3. Any doubt? Okay, some more eigenvalue problems. So A is given as this, 2 minus 12, 1 minus 5. So we can go either with A minus lambda or lambda minus AI. That doesn't matter. You will get lambda minus 2, lambda minus 2, lambda minus of minus 5. So lambda plus 5. And here it is 12 and this must be your minus 1. So your return is on the other way around because lambda minus, we have taken as, see here, A minus lambda I usually will take. But you have taken as lambda I minus A. Both are the same, doesn't matter. Now cross multiplying, you will get this. This will be your quadratic equation. As usual, you will have to factorize. You will get lambda plus 1, lambda plus 2. So your eigenvalues are minus 1 and minus 2. Okay. Now we'll go for the next problem. Here it is 3 by 3 matrix. 2 1 0 0 2 0 0 0 2. So as usual, you will have to write lambda I minus a. We just write in terms of eigenvalue equation like this. Okay, lambda I minus a, which is equal to 0. Then what you can do is you just take these three like this. Instead of going like this, you can take this alone. So you will get lambda minus 2 multiplied by lambda minus 2 multiplied by lambda minus 2. Other terms will be 0 0. Is it okay? Don't go for this and this. You can go for this and this. So you will get lambda minus 2 to the power 3, which is equal to 0. See, lambda minus 2 whole cube equal to 0 means the multiplicity of 3. Okay, lambda minus 2 whole cube equal to 0. We need to have 3 roots here. So that's why it is given as multiplicity of 3. Now A is given as this. We are going to find out the eigenvalue of A. Use as usual A minus lambda I formula. That A minus lambda I, which is given as this matrices 1 minus lambda, 4 minus lambda, 6 minus lambda. As usual, we will have to multiply 1 minus lambda multiplied by 4 minus lambda, 6 minus lambda. Now, which is equal to 0? That A minus lambda equal to 0. So it shows that lambda equals 1, lambda equals 4, lambda equals 6. So 3 eigenvalues are there as 3 by 3 matrix. Very simple one. So now we are going to solve little bit difficult one. This is to calculate the eigenvectors. So earlier we had the calculations, we had seen some examples on eigenvalue problems. We are able to get eigenvalues. Now we are going to get eigenvectors. Eigenvectors is nothing but x. Ax equals lambda x. We have obtained lambda earlier. Now we are going to get x value here, eigenvectors. Okay, this problem is very important. Now let us see, we will start with 2 by 2 matrix. A equals 1 2 3 minus 4, and the lambda 1 is given as minus 5, lambda 2 is given as 2 itself. This is one method. We will go for some other methods later. Now what is this equation? We know that Ax equals lambda x. We know already. Eigenvalue equation. Ax equals lambda x. You just multiply with the matrix multiplication, you will get x1 plus 2x2 equals lambda x1. Correct? Lambda x1. Then 3x1, second one. 3x1 minus 4x2 equals lambda x2. Then you bring lambda x1 this side. You will have 1 minus lambda x1 plus 2x2 equal to 0. Similarly, you bring lambda x2 this side, you will get 3x1 minus 4 plus lambda x2 equal to 0. Is it okay? Now what is given here? Lambda 1 is given as minus 5. You first substitute minus 5 here in this equation. You will get 6. 1 minus of minus 5, that will give you plus 5. So you will get 6x1 plus 2x2 equal to 0. In the second equation becomes 3x1 plus 4 minus 5. Answer is minus 1. So answer is plus x2. Is it okay? I repeat, 4 minus 5. 4 minus 5 is minus 1. Already a minus is there. So this becomes plus. So this is the equation. This can be written in terms of matrices. So we can solve these matrices. Solve this simultaneous equation. You can solve this simultaneous equation. How you are going to solve simultaneous equation? You multiply this by 2 and subtract this equation. You will get x2 value. Then you multiply this equation by 2. Again you just add or subtract, you will get another value x1. So like that only usually we will do. So you will get x1 as this and this. You will get x1 as this is your x1 and this is your x2. Okay. So now you multiply this by 3, that will give you this value. You multiply this one by 3. Digits are going on. 3 2s are 6. But here 7 is there. But you have taken only other digit. Other things and all see, other things are same. 3 6 are see 18. We have 1. 3 1s are 3. 3 plus 1 4. 3 3s are 9. The last digit you will have to take into other digit into account. Only then you will get 7. Okay, is it okay? So now this I can take it as 1. 3 times I can take it as 3. Either way I can write, plus or minus I can write either way. This can be a plus or this can be minus, doesn't matter. Now we'll go for lambda 2 equals 2. Use the same equation, lambda equals 2 here. So you have lambda is 2, so that will become minus x1 plus 2x2. So 3x1, lambda equals 2, it becomes minus 6, so minus 6x2, and you will have x2 is here. The same method, you will multiply by 3 and add these two, you will get x2. So like that you can get x1. You substitute and get the x1 value. So you will get x1 and x2 exactly of this type, and this is exactly twice of this. See here, you multiply this one by 2, you will get this. So I can write this as x2 as 2 comma 1. So this is x1 x2, this is x1 x2, and these are all eigenvectors. Eigenvalues are given, eigenvectors are asked. So this is just on the other way around. Okay. So find the eigenvalues and normalize the eigenvector of a matrix. Okay. So these problems you can find it in any competitive exams. So you have to find out the normalized eigenvectors. So this is not earlier which you have found out is not normalized eigenvectors. But here we are going to find out the normalized eigenvectors, which are very, very important problems. So A is given as this. Okay. We will have to find out eigenvalue, then eigenvectors. That's the answer. A vector is given. We have to find out the eigenvalue. Then we have to find out the normalized eigenvector. So A is given as this. Use the characteristic equation as we have done earlier. We can find the roots easily. We can find the solution. So lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. As usual, s1 is given as main diagonal elements, sum of main diagonal elements. s2 is given as the cofactors or minus of the diagonal elements. s3 is nothing but dirty. So s1, 1 plus 5 plus 1, 7. What is s2? Yeah, what is s2? s2 is nothing but, first you will have to take 5, 1, 1, 1, 1. Next one will be 1, 3, 3, 1. See, 1, 3, 3, 1. Then the last one will be 1, 1, 5. You add all those things, that will give you value s2. Then s3 is nothing but det A. So det A. s3 is nothing but det A. So we have added all the things, we have obtained s2. s3 is nothing but det values is nothing but minus 36. You substitute here. Your lambda cube, see 7. 7 is so minus 11, minus 7 lambda squared, and of course s2 is 0, so there is no lambda term here, and the last one is minus 36, so minus minus plus, that will become plus 36 equal to 0. So we will have to get 3 eigenvalues because lambda cube exists. Okay. Now we will have to solve this one. So we will have to factorize. Factorizing, we have another technique because this is lambda cube is there. So I am going to have this technique. It's very simple technique. We can learn it. This is the equation. Characteristic equation is given by this. Just listen to me. It's very simple one. For lambda cube, just write the coefficient alone. 1 minus 7. 0 is in between for lambda. So you write 0 here. The last one is 36. Is it okay? Now 36 can be just have a separation. 6 multiplied by 6. So you write 6 here. You write 1 minus 0, that will be 1. You multiply 6 multiply 1, that will give you 6. Then you add these two, minus 1. Multiply this one, minus 6. You add these two, you will get minus 30. The last term should be equal to 0. Okay, so now we can write, so if it is so, then we can say that one root is 6, so lambda minus 6. Then another roots are 1 is here, minus 1, minus 6 is there. We can write this as lambda squared minus lambda minus 6 equal to 0. So now you can factorize this. Lambda squared minus lambda minus 6. Minus 6 can be written as minus 3 plus 2. Only then you will have minus 1. Minus, okay. So you have lambda minus 6, lambda minus 3, lambda plus 2. So your eigenvalues are 6, 3, minus 2. Simple one. So you have found out eigenvalues. One part is over. Now we have to go with eigenvectors, normalized eigenvectors. So use A minus lambda A formula. Okay. So det A minus lambda I formula. So this is your A. So A minus lambda I and x, y, z which is equal to 0. A minus lambda I x equal to 0. That is the actual formula which we learned. Okay. A minus lambda I x equal to 0. So x, y, z. First value, just up to first value. Lambda equals 6. So instead of lambda you substitute 6. So you will get 1 minus 6, 5 minus 6, 1 minus 6. Then this matrix can be simplified as exactly like this. Any doubt? Simple one. Now multiply. Now you are going to multiply, matrix multiplication. We will give you the first equation, second equation, third equation. As I said earlier, we can solve these 3 equations using the ordinary method, like multiplying this by 5 and add these two, you will get in terms of y and z. Similarly, you multiply these two with the same number, you will get y and z. That you will have to multiply with y with the same number, you can eliminate y, you can get the value z. Then substitute in terms of y, substitute in terms of x. So you will get it. This is another, this is one method. Or otherwise, we can have simpler method. You write x, y, z like this. You start from the second one. Simple one. You start from the second one. Second one is the coefficient of second one 1. This is 3. Again you go with minus 5 here. You start with C1. For the second one, you start with minus 1. So minus 1 here. Next one is 1. Next one will be 1. Another one will be minus 1. Your x value will be, you multiply this one with a minus sign. So you will have 1 multiplied by 1. So this one will be minus 3, so plus 3. Just minus, subtract. So that will give you 1 plus 3. So the x value will be 4. Simpler again. What are the next one? Y 3 multiplied by 1 minus 5 multiplied by 1 with a minus sign. So 3 plus 5. Next value will be minus 5 multiplied by minus 1, 5. 1 multiplied by 1 with a minus sign. So you have z divided by 1, y divided by first we'll go with x by 4, y by 8, z by 4. Some see, look at your 4, 8, 4. Common terms you can pull it out. So you can write this as 1, 2, 1. So the x value will be 1, y value will be 2, z value will be 1. So that's all. This is another idea, another method. So the eigenvectors are 1, 2, 1. So these are all x1, y1, z1, like x, y, z. So they are all eigenvectors. We have to find out normalized eigenvectors. So for normalized eigenvectors, just take the root, square it. You square the terms under root. So you will get root of 1 square plus root of 2 square plus 1 square, that will give you root 6. You divide this by this. 1 by root 6, comma 2 by root 6, comma 1 by. So this is your normalized eigenvectors. Is it okay? This is ordinary eigenvector. This is normalized eigenvector. Thus we have found out only for one value, lambda equals 5. Correct? We have found out one value, lambda equals 6. We have found out for lambda equals 6. This is one normalized eigenvector. Similarly, we have to find out for lambda equals 3, then another lambda. So as usual, you have to write this as a minus lambda I, det a minus lambda I x equals to 0. Det a minus lambda I x equal to 0. So 1 minus 3. So this is 1 minus lambda. This is 5 minus lambda. This must be 1 minus lambda. Instead of lambda, you have substituted. Then matrix multiplication will give you 3 equations. As usual, you will have to find out the roots. So x, y, z. So you have x, y, z. These are the equations. You can write first 1, 3, minus 2, 1. Then another one will be 2, 1, 1, 2. You will get x by minus 5, y by 5, z divided by minus 5. Take the common terms out, that will give you x as minus 1, y as plus 1, z as minus 1. That's all. So eigenvectors are minus 1, 1, minus 1. So this will be our eigenvectors. How to find out the normalized? As usual, you have to take the square and under root. So that will give you root 3. So minus 1 by root 3, 1 by root 3, minus 1 by root 3. So this is your normalized eigenvectors. Then lambda equals minus 2. As usual, take the That A minus lambda x equals 0, you will get this equation. This equation can be simplified as this. You have to multiply these, you will get 3 equations. Simplified form, you will have to write to find out x, y, z. You will get x divided by this, y divided by 3 minus 3, z divided by 21 minus 1. You will get exactly like this. Take the common terms out, that will give you x minus 1. This as it is 0, so z by 1. So minus 1, 0, 1 will be your eigenvectors. To find out the normalized eigenvectors, just square it, take under root, so that will give you have root 2. So this becomes minus 1 by root 2, 0 by root 2, 1 by root 2. So these are all normalized eigenvectors for the corresponding eigenvalue. For the corresponding eigenvalue, lambda equals minus 2. Okay, any doubt? Eigenvalues and eigenvectors are 3 by 3 matrices. So now we will try to solve one problem. So vector matrix A is given as this. As usual, we will have to find out the eigenvalues and eigenvectors. We are going to find out. How many eigenvalues will get? 3 eigenvalues. This is 3 by 3 matrix. So 3 eigenvalues we will get. So as usual, A minus lambda I equals 0. As usual. So M minus lambda I, both are the same. Doesn't matter. In some other book you may find M minus lambda I. In some other book you will find lambda I minus M, lambda I minus A. Doesn't matter. Everything will give you the same answer. So A minus lambda I equal to 0 will give you this. Correct? You will have to take that. So that will give you 2 minus lambda, you pull it out, you will get this. This is equal to 0. So 2 minus lambda I have simplified this one. You will get, ultimately you will get this equation, lambda cube minus 6 lambda squared plus 11 lambda minus 6 equal to 0. See here, I repeat, see here you will have to take 2 minus lambda and you will have to take this one. Here it is minus, one minus is there already. You will have to take the cofactor. So minus, so this becomes plus. You will have to take 3 this one, 3 multiply this, see. And the next one. Next one is 3 minus 1 minus 3 lambda 1. And you will have to multiply these two, you will get this, you will have to multiply these two, you will get this, last one you will get this. Simplify, you will get this equation. Okay, now this is lambda cube minus 6 lambda square plus 11 lambda minus 6. I have factorized now. So that is your assignment. Next assignment will be this one. You will have to factorize. So you will get the value, you will get, surely you will get 3 values. Those 3 values will be 1, minus 2, minus, no, 1, 2, 3. Lambda minus 1, lambda minus 2, lambda minus 3 equal to 0. So that will be 1, 2, 3. So to find out eigenvectors, first you will have to go with lambda equals 1. So lambda equals 1. So this is your A minus lambda x equal to 0. Matrix multiplication will give you 3 equations. 3 equations. And you have solved in a different way. See here, as I said earlier, multiply this by 3. You will get 3x minus 3y plus 18z. Multiply this with a minus sign, with 2. What is that? See here, multiply equation 1 by 3. Then you will have to have minus sign. This is minus sign. That is, you will have to subtract. Then 3x and 3x will get cancelled. You will have only in terms of y and z. So y equals 9z. Is it clear? This is what I said earlier. Can you remember? This way also is simple way. That way also is very simple way. Either way you can do it. I said multiply this by 3. You subtract this by this. The 3x will get cancelled. You will have y in terms of z. Y in terms of z. Now y is in terms of z, you substitute here. You will get x minus 9z plus 6z. X equals 3z. So y equals 9z, x equals 3z. You substitute z equal to 1. Any one you can substitute. X equal to minus, z equal to minus 1 you can substitute. 1, 2, 3, anything you can substitute. Suppose z equal to 1. Z equal to 1. X will be 3. What about y? Y will be 9. So this is your eigenvectors. 3, 9, 1. You will have some other eigenvectors too. Suppose you are going to substitute minus 1. You will have different eigenvectors. Doesn't matter. It's the same. Okay. Now lambda equal to 2, you will get eigenvectors as this one. Lambda equal to 3, you will get the eigenvectors as 1, 5, 1. Okay. So that's all. So in the class, this is a lengthier class. We tried to solve so many problems. We started with 2 by 2 matrix, and we have found out det A. We have found out the eigenvalues, eigenvectors of 3 by 3 matrix in different ways. Okay, then we started with the characteristic equation. So eigenvalues, they always go only with a linear transformation. So this is very, very important thing. Linear transformation, only stretching. Okay, so we'll stop today. We will see in the next class. Bye, students.